Okay, let's talk about some more cell phone DC electronics. So this time I want to talk about the multimeter. I remember the multimeter when I first started doing electronics. I looked at it and I was like, I have no idea what this is. I didn't know what the settings meant. I didn't know what the symbols meant. I didn't know what the little holes at the bottom meant. The red and the black probe. All of it was just, I guess, mind boggling to me. And even somebody who maybe has taken some classes may still not totally understand the multimeter and its functions. So let's go through them real quick. I like this picture because it labels everything and it's very easy to understand the relation to all the symbols and what they mean in terms of what you can do with them. So in this one, I do notice that common ground has been mislabeled, and essentially the red and the black probe should be switched. But a lot of times multimeters do have 2 or 3 terminals at the bottom for your probes, and that's where your probes plug in. The black probe always goes to the black hole, and the red probe could go to one of 2 ways. And for this multimeter, it has 2 means. It has an amp meter and a voltmeter. If you plug it into the one hole, the current terminal, essentially you're putting the multimeter into a circuit inside of that circuit. It's part of the circuit. It's wired in series with the rest of the circuit. If you put it into the voltage area, the voltage terminal on the other side where it says voltage frequency resistance terminal, then what you're doing is you're putting this multimeter in parallel with the circuit that you're measuring. So the multimeter doesn't need to be a part of the circuit. You can observe the circuit from the outside. And starting from the off label on the multimeter on the left side, I'd like to go through each symbol and describe it a little bit. So the symbol on the left is off. There's one on the right as well. Either one works just as well. Please don't get confused by that. You can set the selector switch on either side. It turns the voltmeter or multimeter off. Now above that is a voltage sign V with a straight line and a dashed line. That is your DC voltage. And that means that your voltage is being measured in one way. It's traveling one way. It's traveling from, in a traditional sense, it's traveling from black to red, positive to negative. I'm sorry. The traditional sense is red to black, positive to negative. Now with AC voltage, your positive and negative terminals alternate. They switch. And so the circuit inside of the multimeter is set up to be able to measure that. And you would set it to that AC voltage symbol, the selector switch to the AC voltage symbol to measure AC voltage, like if you are an electrician and you are measuring voltage at a house to see if you have 120 volts coming out of a socket. AC voltage. Not something we're going to talk about, but it's there. the arrow covers up a squiggly line. If you look on a multimeter, there's two V's. There's the straight line with the dashes, and then there's the squiggly line with the V as well. The straight line is the DC, the squiggly is the AC. And then above that is an ohm symbol. That's resistance. This is you measuring the resistance most likely of a resistor. Could be some other things, but most likely a resistor. And then above that is a symbol that we haven't talked about, but it's a diode symbol. And then there's also a sound wave symbol as well. The diode symbol is for a diode measurement. Essentially, the multimeter puts a small load, voltage load, where you probe it and measures what that voltage drop is. So for instance, if you were to measure the voltage drop of a diode, it's usually between 0.4 and 0.7 millivolts. And so it's used for diode it's used for diode measuring diodes usually, but you can use it for other reasons. You can use it to find a lot of different readings within a circuit that you should be able to find based on it injecting a small voltage and reading that voltage. It's pretty consistent across the board between all of the circuits. So if the place that your diode reading shows a dramatic variation in what you're expecting, most likely that component is not performing the way it should perform. So if you put 1 volts over a resistor at 100 ohms, that diode reading would give you a reading of a specific amount. It would say a specific amount. And you could do that 9 times out of 10 and get within a certain tolerance of a number. But if that resistor is failing, or if it's a capacitor, or if it's something else, then it's not able to maintain that same number because it is failing. It doesn't have that capacity anymore. And so the diode mode is great because it gives you a lot of information about the state of the circuit that you're analyzing. In that setting also is the little sound waves. That's continuity, and that's the beeping. You've probably heard of this continuity mode before. It's pretty common. It's a good way of finding a short to ground. You put the red probe on your ground plane and your black probe wherever you're looking. If the component is not supposed to be shorted to ground, but it is, it'll beep. Anything that touches ground, if you have one probe on ground and you touch the other probe to any other component, and if it's on ground, you'll know because it'll beep. So the beeping is crucial for finding components that have failed as a short to ground. If they've shorted to ground, then there's continuity between the two components and there shouldn't be. Especially something like a capacitor, because a capacitor is an open unless there's a fair amount of voltage through it. And a diode voltage isn't high enough for that capacitor to pass its electrons between its internals. So above that is frequency. Frequency is used for more higher level electronics, using electronics as a means of, it can be communication between different chips, computer chips. And wouldn't be used too much by the common tech, I don't believe. And then you get over to the current side. There's three settings for current, and they're all AC current settings. You would be able to probably read DC current settings in it as well, and that's why they only have AC assigned, because it could probably do both. The thing with the current is that current is much more able to damage a computer chip or a PCB chip, any kind of circuit. Too much current basically causes too much load on components, heat dissipation, damage to the components, wear and tear, and this causes components to fail. So there's a lot of safeguards put in place on the current side of a multimeter, like a fuse, in order to prevent either damage to the multimeter or damage to the circuit itself. And that's why there's 3 ranges. It's not necessarily auto-ranged, which means that it finds the range within the multimeter itself instead of you selecting between a bunch of different denominations of the measurement that you're taking. For this one, it's microamps, milliamps, and then amps. And I'm guessing amps is fused, has a fuse in it for at least 10 amps, which is a lot of current. So that's the multimeter. Obviously, you can see the little digital LCD display, and it shows a 0.020. That 0.020 means it's less than a whole amp. And we'll talk about that more in the next part.